Okay, examine this experimental setup. It says that Rita was given two identical beakers X and Y, a ball and a stone tied to similar strings were placed in each beaker and water was poured into them until they reached the same level. So you mentioned this part, the same level. So I want you to annotate this part during your exam. You use a ruler, right, to do the dotted line. So these two levels are the same. Okay, what does this show? That means the water, okay, because they say the water was poured into them until they reach the same level. Okay, we cannot assume they are the same volume. They just tell you that after they are lowered, right, they pour the water until they reach the same level. So this is testing your understanding of displacement. Okay, without changing the setup, suggest a way for Rita to find out which object has a greater volume. So actually, logically, I think most of you know how to do it, right? But you may have difficulty in explaining. So actually, it's very simple. You remove both, right? You remove both this from the water, and then you will check the new water level. So if beaker X has a lower water level, right, it means that the ball has a greater volume than the stone. Okay, this is what the answer means. So you remove both the balls and the stone from the beaker using the string and observe the water level. So I'll put it here. Okay, remove the ball and the stone from the beakers using the string and observe the water level. The beaker with lower water level is the object with greater volume. Okay, this is how you explain this part. Simple and sweet. Okay, there's a typo error here. Which property of solid, not of, no OFF. So you change this. Which property of solid is shown in this experiment? Okay, so actually you should say solid occupies space or solid has definite volume. Solid occupies space may be better. So we accept both. Solid has definite volume or solid occupies space. So both accepted. These two. Okay, these two part. Okay, I screenshot this. Okay, next question. So part C, part D. Okay, part C is over here. I separate the paper because I want to mark the students' work. So the ball and stone were placed on a beam balance. So actually beam balance compare masses. They say the beam was at a horizontal position when 10 grams was being placed here. So you notice this 10 grams, right, is used to balance both. So from here we understand that the mass of the ball will be lesser than mass of the stone. Because some students, they do not understand what's the meaning of infer. Okay, infer means what can you say from the observation here. So from the observation here, you can either say the stone has a lesser mass, as the stone has a greater mass than the ball, or you can say the ball has a lesser mass than the stone. So both acceptable. Or you can use the word heavier also can. Okay. So these are the acceptable answer. The stone has a heavier or greater or more mass than the ball. Okay, so this part I've gone through this part. So I will do a screen share also later. Okay, but I will finish this question first before I stop the recording. Then we'll take a short break. Okay, this is an important question, so I want you to annotate this part of this question. Okay, this question actually tests the concept of heat. Okay, let me enlarge it to explain. Okay, Armin wants to find out how air in the bubble can slow down. So you annotate this. This is the purpose of the experiment. How air in the bubble wrap can slow down heat loss. So you can actually annotate. This is the aim of the experiment. He wrapped a container with a layer of bubble wrap containing pockets of air and then pour in 100 ml of boiling water. So you understand the setup, right? So he wrapped this first and then he pour in boiling water inside. 100 degrees. Okay, boiling water means 100 degrees. 100 ml of 100 degrees. He measured the temperature of water after every 15 minutes. Amin repeated the experiment with more layer of bubble wrap and recorded the result as shown. So even before you see the result, right, mentally you should know the more layer of bubble wraps is being wrapped, right, it will take a longer time for the water to lose heat. So let's review whether it's true. Yeah, that is true. Can you see? This is a control setup. 0 bubble wrap. It takes, okay, after every 15 minutes the temperature is measured. So without any protection, the temperature dropped from 100 to 46 in 15 minutes without any protection. With one layer of protection, temperature dropped to 57. So lesser drop, right? With second layer, 2 layer, even lesser, drop to 66. And with third layer is the least. It dropped only to 75. So you understand this setup? Good. So from here, then you can understand how to proceed to the questions. Okay, based on the result. Okay, this one, please highlight, because some students, they do not base on result, they base on what they think. So this important parameter, based on the result of the setup, what is the relationship between what? Between the amount of air trapped in the air in a bubble wrap and the temperature of water after 15 minutes. Okay, for this type of questions, I have told students many times, or unteam times, the new word, unteam means many times, that they just copy this thing, okay? Just copy between what? Between the amount of air trapped in the bubble wrap and the temperature of water. So don't use other words. So you just copy this. You say, as the amount of air, okay, as the amount of air trapped in the bubble wrap increases, what happened? The temperature of water after 15 minutes decrease less. Okay, so I just put here this part. Okay, I make it very clear for you to understand. Okay, so can you see I copy exactly the same words? Okay, this part, let me arrange it. Okay, this part. Can you see? As the amount of air trapped, so this part, amount of air trapped in the bubble wrap, what happened? Increases. Okay, which is, look at this diagram here. Because more layer means more air, because I'm using the actual words. Okay, so you just copy here. As the amount of air trapped in the bubble wrap increases, what happened to the temperature of water after 15 minutes? The temperature of water, can you see? I copy this one. The temperature of water after 15 minutes, what happened? Decreases less. Okay, can you see this one? If you want one layer is 57, more layer is 75, so decrease less. So this is the answer. Okay, another way to answer is, as the amount of air trapped in the air bubble increases, the temperature of water after 15 minutes would be higher. Or you say decrease less. Because why I say decrease less? Because it decreases lesser from 100 to whatever the temperature is. Okay, so you take note of this. Okay, this question, put an asterisk here. Many students know how to answer, but don't know how to phrase. Okay, so they say, why did he conduct the experiment with no bubble wrap? So I told you, right, this no bubble wrap is a control setup, but how do you phrase the answer? Okay, how to phrase the answer depends on what they want to measure. So that's why earlier I told you, right, it's important to put down the aim. The aim of the experiment is to find out how air in the air bubble slow down heat loss, right? Correct? So your answer must have something to do with this. So firstly, you must say it acts as a control setup to confirm, okay, to compare and confirm. Okay, this is a new phrase that I like to teach you, to compare and to confirm. Okay, let me put the answer here. Okay, it acts as a control setup to compare and confirm that the changes in temperature of water after 15 minutes is due to the number of layer of bubble wrap. Okay, can you see the question here? The air in the how much air? So you can either say due to the number of layers of bubble wrap or due to the amount of air trapped in the bubble wrap. Means more layer means more air. So you take note of this, this part. Important things to take note. Okay, so this is important questions. Okay, let me continue the next part before I give you a short break. Okay, next, a greenhouse needs to be kept warm on cold days and cool on hot days. Some greenhouses have pockets of air in their roof in order not to become too hot, too cold or too hot. So actually I give you one example here. If you visit the Gardens by the Bay Flower Dome or Cloud Forest, right, if you examine, they have this, some parts of it, they have this window trapping pockets of air. So they show here, between two sheets of material F, there's a pocket of air. And the volume of each pocket could be changed as air is being pumped in or pumped out of the pocket. So here they say, explain how this setup use a property, so underline this word, use a property of air. So what is this property of air? The property is air is a poor conductor of heat. Okay. So your question, you should say, air is a poor conductor of heat. By pumping more air into the pocket, right, more heat can be trapped, thus reducing heat loss to the surrounding. Okay, because why heat loss? Because they give you a specific purpose. The specific purpose is allow the greenhouse, right, to keep warm on a cold day. So this is to help you. Okay, because they can serve another purpose. The other purpose is to, when the weather is hot, right, to keep it cold. So now they already identify here, I want to keep warm on a cold day. So your answer is, you must mention that to keep warm, right, I want to reduce heat loss. Okay. So your answer should be in this manner. The property of air you must state first. So air is a poor conductor of heat. Okay. Air is a poor conductor of heat. By pumping more air into the pocket, more heat can be trapped. Okay, more heat can be trapped, or more heat can be trapped. Okay, thus reduce heat loss to the surrounding. Okay, more by pumping more air into the pocket, more heat can be trapped, thus reducing heat loss to the surrounding. Okay, quite easy to get these 2 marks. Okay, next, the plants in a greenhouse are still able to make food during the day. What is the property of material F that enables this to take place? So the material F you have to see here, right, is this one. Because light can pass through, right? So this property is, it allows more light to pass through, okay, or it is transparent. Okay, it allows most light to pass through. Okay. Or you can say it is transparent. Okay, so this question, do take note of this one, and I will screenshot this. So this once again is an important question. If you look at this question in this exam, right, I believe it's a 5-mark questions. There's 1, 2, 4 plus 1, 5. So this is a 5-mark questions. Right? So in our PSLE, there's a 5-mark questions being tested. Okay, so take note of this.